Okay. Hello all. In this video, I'm going to explain about frequency integration property. Okay. Last video we learned about the frequency differentiation property. In frequency differentiation property, we apply the property when the signal is multiplied by the time function t. Okay, so anywhere when you will see this function t into x of t, then immediately you apply the frequency differentiation property. Okay, likewise this is called as frequency integration property. This property you apply when your signal or when your question is divided by t. T is time. Okay, anywhere wherever you see t at the denominator, okay, anywhere wherever you see the t at the denominator, immediately you should understand that the property you need to apply is frequency integration property. Okay, so let's see what the property is. If Laplace transform of x of t is equal to x of s, then the Laplace transform of x of t by t is equal to integral s to infinity x of s into ds. Okay, this is the equation, right? So here as you can see, x of t is my signal and this signal is divided by time t. So if you see if you see a question in this format, then immediately you should understand that this is the property you need to apply. Okay, here x of s is the Laplace transform of x of t. Okay, so all you need to do is first find the Laplace transform of x of t and then you integrate it from s to infinity. That's all. Okay, so here's the proof. We know that the Laplace transform of x of t, that is x of s, is equal to integral 0 to infinity x of t into e raised to minus st dt. Okay, so now what I'm going to do is I'm going to find the value of integral s to infinity x of s ds. Okay, so I'm going to substitute this x of s, that is this equation over here. So I will get integral s to infinity, this is my Laplace transform x of s. Okay, integral 0 to infinity x of t e raised to minus st dt ds. Okay, so now what I'm going to do is I'm going to bring this integration inside. Okay, this integration inside. Okay, the reason is because this integration is with respect to s. Okay, and if you look at this equation, the only place that has s is over here, that is e raised to minus st. So I will bring this integration inside. So interchanging the integration, then this equation will become integral 0 to infinity x of t into this integration I have brought inside, and it's only affecting my e raised to minus st. So integral s to infinity e raised to minus st ds dt. Okay, so I only need to integrate this part with respect to s. Integrating this means then s is my variable and t is my constant. Okay, so when I'm integrating this, I will get e raised to minus st by minus t. Okay, so integral 0 to infinity x of t into e raised to minus st by minus t from s to infinity dt. Okay, so now I'm going to substitute the value of infinity and s in this variable. Okay, so what you will get? You will get integral 0 to infinity x of t into this infinity over here, it become e raised to minus infinity minus this s over here, it will become e raised to minus st by minus t dt. Okay, we know that the e raised to minus infinity is 0, so this will become 0, this will become e raised to minus st itself. Alright, and when you integrate it, so in the next step you will have this minus and minus will get cancelled. So in the next step you will have integral 0 to infinity x of t into e raised to minus st dt. Okay, so now this t I can bring it over here, so this will become integral 0 to infinity x of t by t into e raised to minus st dt. Okay, so you see this is, you know, the equation for Laplace transform is integral 0 to infinity x of t e raised to minus st dt. Here it is integral 0 to infinity x of t by t into e raised to minus st dt. So this is nothing but the Laplace transform of this. This is nothing but the Laplace transform of this. Laplace transform of x of t by t. Or in other words, the Laplace transform of x of t by t is nothing but integral s to infinity x of s ds. Okay, this is how we do the derivation, right? So now we'll do the problems. Okay, so before doing the problems, I just need to give you some basic tips of how to approach these kinds of problems. That means problems that has integral over here. Okay, for that all you need to do is simply learn these basic equations. Okay, these equations are very simple, they are not at all difficult to remember. All you need to do is just study these 7 equations, and then you can apply those equations in your given problems. Okay, some of these equations are you have already studied in your maths class. Okay, the only difference is that here there in maths class you use the variable x, here I use the variable s, because we are using Laplace transform variable s, so I'm using s over here. Okay, so here the equation over here is integral 1 by s ds is equal to log s plus c. C is the integration constant. Of course, this you can neglect when you're doing your Laplace transform problems. Okay, this c has no significance in your Laplace transform problems. Okay, so integral 1 by s ds is equal to log s. Next equation is integral 1 by s plus a ds is equal to log of s plus a. So you can understand, if you integrate the reciprocal, just put a log in front of it. That's all. You see, so these 2 equations are very easy. Okay, likewise, so third equation also, integral 1 by s minus a ds is nothing but log of s minus a plus c. Okay, usually we write natural logarithm, or you can write logarithm also. Okay, that depends on where you are applying this equation. Right, so here we are using log function. So integral 1 by s minus a ds is equal to log of s minus a plus c. So in these 3 equations, just because the reciprocal is s plus a and s minus a, then the logarithmic function will be of log s plus a and log s minus a. Okay, now this equation you have to learn as such it is. Okay, there is no separate derivation you need to study. It is derivation will be very lengthy, so you can't apply the derivation itself to this formula. So this formula you need to study. All right, this formula you have also learned this formula. That is integral a by s square plus a square ds is equal to tan inverse s by a plus c. Okay, this formula you need to keep in your mind. This is the only formula you need to keep in your mind. Okay, integral a by s square plus a square ds. All right, you must have studied like this: integral 1 by x square plus a square dx is equal to 1 by a tan inverse x by a. That's how you must have studied. Same thing over here. Okay, the reason you'll understand why I have used a by s square plus a square. You have already seen this in many places. Likewise also over here. Okay, these 3 equations, it is better that you study these equations and formulas. If you are able to keep this in your mind, it's well and good. Okay, but suppose if you cannot remember these 3 equations, suppose you forgot these 3 equations, it's okay, we can derive it, provided you should be able to do maths very fast. Okay, it's a simple technique to remember these formulas. It's a very simple technique, but the thing is, when you are doing this, you have to be real fast, because there are no step marks for finding the integration. You see, this is not a maths class, so they will not give you any step marks for finding the integration. So when you are going to find the derivation of these formulas, you have to do it very fast without wasting any time. Okay, because so that's one thing. So this is integral a by s square minus a square ds is equal to 1 by 2 log of s minus a by s plus a. This is now 5th equation. 6th equation is integral s by s square plus a square ds 1 by 2 log of x square plus a square plus c. And the 7th equation is integral s by s square minus a square ds is equal to 1 by 2 log of s square minus a square. Okay, I hope some of you by now should have already understood why are we using these integrations. Why do I have to study only these 7 integral formulas? If you can see very carefully, you have already seen these terms, right? This is nothing but the Laplace transform of u of t, or Laplace transform of 1. This is nothing but the Laplace transform of e raised to minus at. This is the Laplace transform of e raised to plus at. This is the Laplace transform of sin at, right? This is the Laplace transform of sin at. This is the Laplace transform of sin h at. This is the Laplace transform of cos at. And this is the Laplace transform of cos h at. You see? So these formulas you are usually applying. You usually apply these formulas when you are finding the value of, for example, if I want to find the Laplace transform of sine at by t. Okay, so you know the frequency integration theorem. That is nothing but you have to integrate x of s, right? You have to integrate x of s from s to infinity, and this is your x of s, right? X of t is sine at, so the Laplace transform of sine at is this one, a by s square plus a square. You see, that is why we need to study these 7 formulas. Okay, so like I said, the first 4 formula, the first 3 is very easy. Just take the what is the reciprocal over here, okay, and write it at log of that reciprocal. Okay, here you have to remember this formula. This is the only formula you need to remember. A by s square plus a square ds is equal to tan inverse s by a. Okay, these 3 formulas, even if you cannot remember also, is still okay. You can still derive it while you're doing the problems. Okay, so I'm going to do my problems assuming that I don't know these equations. Okay, but I know the first 4. But I don't know these 5. Under that assumption, I will do these problems, and then I will show you how to derive it. Okay, so let's do the first problem. Find the Laplace transform of the following signals. First question is sine at by t. Second question is e raised to plus at minus cos 3t. Third question is sine square at by t. And the fourth question is 1 minus e raised to t by t. You see, so if you see these kind of questions, that means in the denominator there is a t. Okay, if you see these questions, immediately you should understand that you need to apply frequency integration theorem. Okay, so let's do the first question. First question, sine at by t. Okay, you're going to find the Laplace transform of this. So I'm going to write my property. We know that the Laplace transform of x of t by t is equal to integral s to infinity x of s ds, right? This is my frequency integration property. Here my x of t is sine at, right? This is my x of t, right? So in that case, my x of s is nothing but the Laplace transform of sine at, which is nothing but a by s square plus a square. Okay, so therefore the Laplace transform of sine at by t is equal to integral s to infinity a by s square plus a square, because this is my x of s. Okay, this is my x of s. Okay, so we already know this equation of this, a by s square plus a square. This is nothing but tan inverse s by a from s to infinity. Okay, and this is nothing but tan inverse of infinity minus tan inverse of s by a. Okay, so we know what is tan inverse of infinity. Tan 90 degree is not defined, right? Tan 90 degree is not defined, so tan inverse of infinity is 90 degree. Okay, 90 degree, pi by 2 minus tan inverse of s by a. That's it. Okay, this is your answer.